Hello friends, in this AV we are going to take up the numericals of chapter 10 of class 10 physics, that is electromagnetism. We would be talking about the numericals of exercise 10C, which are basically based on EMF, flux and the transformers. So let's take up the first numerical, which says the magnetic flux through a coil having 100 turns decreases from 5 milliweber to 0. That means the change in the magnetic flux is 5 minus 0, that is 5 in 5 seconds. So this is the time. We have to calculate the EMF induced in the coil. So here we are going to use the formula for induced EMF, that is induced EMF is equal to change in flux multiplied by number of turns in the coil divided by time in which the flux changes. So here the change in the flux, as I told you, is 5 minus 0, that is 5, multiplied by number of turns in the coil, that is 100, divided by time in which the flux changes, that is in 5 seconds. So you just cancel out 5 and 5, and 100 is the answer for the first part of the question, 100 millivolt. Now the second numerical says the primary coil of a transformer has 800 turns, that is NP is 800, that means number of turns at the primary side, and the secondary coil has 8 turns, that is NS is 8. It is connected to 220 volt AC supply. That means the input voltage or EP is 220 volt. What will be the output voltage? So here we are just going to use the ratio formula. So for number 2 we have written the given things. NP is equal to 800, NS is equal to 8, input supply voltage EP is 200. These informations are provided to us in the question itself. So we know that the input voltage divided by output voltage or output supply is equal to number of turns at the primary divided by number of turns at the secondary of the transformer. So here if we rearrange the terms and convert this equation in terms of ES, then ES is equal to NS multiplied by EP divided by NP. So number of turns at the secondary is 8 multiplied by EP, that is 220, divided by 800. So when you calculate this, you get the answer as 2.2 volts. Now the third numerical says a transformer is designed to give a supply of 8 volt to ring a house bell from the 240 volt AC mains. The primary coil has 4800 turns. How many turns will be in the secondary coil? Again we are going to use the same formula, EP upon ES is equal to NP upon NS. So here for number 3 we have written input AC voltage, that is EP is 240, NP is equal to 4800, output voltage ES is equal to 8 volt. We have to calculate NS, that is number of turns at the secondary side of the transformer. So we know EP upon ES is equal to NP upon NS. So NS is equal to NP multiplied by ES upon EP. So we just substitute the values, and after simplifying we get the answer as number of turns at the secondary side of the transformer is 160. These are very easy numericals. Now we go to the last numerical, which says the input and output voltages of a transformer are 220 volts and 44 volts respectively. We have to find the turns ratio. Turns ratio means NS upon NP. And we have to find the current in the input circuit if the output current is 2 ampere. So for this Please see here. We know that EP upon ES is equal to NP upon NS. We are going to use this equation. So for turns ratio, this portion of the equation talks about the number of turns at primary upon number of turns at secondary. So we write NS upon NP is equal to 44 upon 220, that is equal to 1 upon 5. So the turn ratio will be 1:5. That will be the answer. And the second part of the question says that we have to find out the input current or the current at the primary section. So Is is equal to 2 ampere, Es is equal to 44 volt, Ep is equal to 220 volt, Ip is what we have to calculate. So here, instead of number of turns, we are using the current at the secondary and current at the primary part of the transformer. So that equation or that relation is Es multiplied by Is is equal to Ep multiplied by Ip. So here we have, basically this is the multiplication of voltage and current at the primary, which will be equal to the voltage and current multiplication at the secondary side of the transformer. So from here Ip will be, just Ep will go this side, so Ip is equal to Es into Is divided by Ep. So that is equal to, we just substitute the value 44 multiplied by 2 upon 220, and after simplification we get it as 0.4 ampere. So the output current is going to be 0.4 ampere. That's all we have in this AV for you. God bless. Thank you so much.